Okay, this is 8.1 to I don't even know anymore. It's 8.1 to something. Uh, define internal energy. Okay, it's in the here. Internal energy is equal to the sum of its random kinetic, the chemical potential, and the intermolecular. Oh my god! And the intermolecular potential and the chemical potential. فيعني random kinetic, chemical potential, intermolecular potential. Memorize it. Question 2. Determine, okay, depending on the context, heat energy can refer to the random thermal, the internal energy, and the radiant energy. Okay, it's all here. Where is it? Here. The random thermal, radiant energy, and the, what do you call it? Internal energy. Okay, question 3. Okay, energy exchange. Over. Okay, energy is the ability to cause a change. This came last time. When it comes to having an energy transfer, okay, if a body is moving in, let's say, it's moving in constant speed, constant direction, obviously no energy transfer. Okay, let's say it's a constant speed, okay, but wait 1 second. Sorry, but I decided to change the direction now. Instead of going to the right, I'm going to the left. Constant speed, but to the left. Is there an energy transfer? No. Okay, because I'm still at a constant speed. But what if I same constant direction, but the velocity decreased? Obviously, to decrease, I had to apply a force. So there is energy transfer when the velocity changes. So when you're starting to move direction, when you cause a change, that's that's when there's energy exchange. So here above, moving uniformly in a circle. So moving uniformly, and it's moving at a constant speed. It's staying like this, nothing's happening. So is there energy exchange? No, without energy exchange. But a man, okay, man holding a box above his head. Did they say hold or did they say lift? They said hold. Okay, not lift. Hold means the guy is standing. He's standing still, and the box is above his head. He's not moving. So that means no energy exchange. A spring being compressed, of course, is energy exchange. You're pushing on the spring, you're compressing it tight. And then the last one, a bob is swinging up and down. Okay, how's this going? How's this way? A bob swinging up and down. How is this with energy exchange? Am I tweaking ولا because it says it in the book. The bob, okay, rotating at a constant speed, interacts without energy exchange. Am I tweaking? A bob on a vertical spring swinging up and down. Ya Allah. Man, why does this happen to me, أخي? Okay, I think I'm drunk. A bob on a vertical spring. Okay, in the book it's saying no energy exchange. Here it's saying energy exchange. مش فاهم صراحة. Okay, wait. I think because here it's a pendulum, it's rotating left and right. Okay, so this stays like that. The direction is staying the same. But here, I think because it's going up and down, I think it loses energy. I think it loses energy when it's going up and down. I think there's gonna be energy exchange here. Okay, we did this, we did the rest. So like, okay, see, the one moving uniformly, that's without energy exchange, but it's swinging up and down. I think because, well, I don't know. I actually don't know. I think because it's going up and down, it's different than moving uniformly. I think because they didn't mention there's a constant speed. And they won't get something stupid like this in the exam. Okay, a body is changing its speed, but not its direction. If it's changing its speed, there's energy exchange. Okay, body is changing its direction and its speed. Again, changing speed, energy exchange. Body remains stationary, so it's staying. The velocity is not changing, so there's no energy exchange. Here also it's changing direction of motion, but not the speed, so the speed stayed constant without energy exchange. Question 5. Okay, to build a fire, ancient people used rocks called fire strikers and small pieces of wood. So the kinetic energy of the fire strikers is moving against each other. Keyword is moving. Whenever you see moving, that's kinetic. Okay, produces a spark and warms the pieces of wood, supplying them with some thermal. Again, warm, keyword for thermal. Okay, as the wood burns, it's stored chemical energy because into when it burns, the stored is usually chemical. Okay, releases more thermal energy. When it's burning, obviously it's releasing thermal energy. Question 6. Okay, to charge your mobile phone, you plug it into a socket. Obviously, electrical energy. So this electrical energy is turned into the battery as chemical energy. When it rings, obviously, sound energy, and the display of the screen is light energy. Okay, and nothing too hard. Okay, question 7. When the energy changes from one form to another, we say it's transformed, and when it's given from one body to another, it's transferred. I think this is any basics. Question 8. Okay, heat can be split into three categories. We said the random thermal energy, the radiant energy, and the internal energy. The random thermal, okay, would be a warm piece of iron. This is how they explain it in the book. I'm going to show you how to do it. Radiant is always infrared. Okay, red radiant. That's how I do it. Okay, internal energy, I put like it's inside the hot steam. Okay, when it's physically inside and it's internal. Radiant, infrared, and then random thermal. And just the last one. You just pick the last one. Question 9. Okay, this is all in the book. Basically, there's this theory called the second law of thermodynamics. Okay, basically what it is, if I have a hot object, 70 degrees Celsius, and have another object 30 degrees Celsius, this hot object will lose heat to the cold object. It always goes. Basically, the law says it goes from the one with more energy to the one with less energy. Okay, that's how it happens. So that's what the second law of thermodynamics is. And no energy dilutes itself. Dilutes meaning goes from more concentrated, higher energy to less concentrated energy. Okay. What's this law called? The second law of thermodynamics. Okay, what is the most dilute form of energy? The random molecular kinetic energy. This is the most dilute, and this is the furthest you can go. After this, you can't do anything. You can't dilute after random kinetic energy. As random molecular kinetic energy. Okay, here you have deuterium atom. Deuterium is hydrogen 1, 2. Uh, this is another deuterium atom, obviously, because they look the same. If I just fill it in, another hydrogen 1, 2. Okay, they fuse together to make a big atom. And add these up, 1 and 1 is 2, 2 and 2, 4. So it's going to be helium. What's 2, 4? It's helium. You guys know it's helium. Also, that's how helium atoms form, from the combination of two hydrogen atoms. And obviously, since it's fusion, it releases some energy. Question 11. Okay, the nutritional value indicates the amount of chemical energy stored in the food product. The nutritional value of apples is 52 calories per 100 grams. So let's write that, 52 calories per 100 grams. The average apple is 150 grams. Okay, they're saying 1 calorie is 4.2 times 10 to the power of 3, and the speed of light is 3 times 10 to the power of 8. The nutritional value of an average apple. Okay, an average apple is 150 grams. How many calories does it have? X calories, right? So just cross multiply, and you get 78. The nutritional value of an average apple, how many joules? We know how much calories. How do we find the joules? Just multiply by, they give us a conversion factor, 4.2 times 10 to the power of 3, and you get 327.7, I think. Let me do it here. 4.2 times 10 to the power of 3 times, what was it? Times 78. 8 times 4.2. You get 327.6 thousand, I think. But they want it in kilojoules. You have to divide by 1000, you get 327.6. Rounded to 3 significant figures, that's 328. Okay, the last one. If all the mass is converted into energy, how much energy will you have? Okay, energy and mass, how are they related? E equals mc squared. Mass has to be in kilograms, huh? So E equals the mass in kilograms. So 150 grams in kilograms, 0.15. Okay, times c squared, which is 3 times 10 to the power of 8 squared. Put this in a calculator, you get a long number. Let me do 0.15 times 3 times 10 to the power of 8. 3 times 10 to the power of 8 squared. Yeah, you get this. And you have, whoa, you have 6, 12, 15, 16. Yeah, times 10 to the power of 16, they gave it. So you just put it 1.35. Huh? Question 12. What metal of radiant energy explains the ability of light to, okay, look here. Over here, here, from here, light can be waves or particles. Usually it's particles. They started out with the photoelectric effect and they said it's a particle. Then they disproved it over here with interference. Okay, they figured out that light can pass through narrow openings, and that isn't how a particle behaves, that's how waves behave. But then they distinguished light into two different categories, particles and waves. So when it comes to the photoelectric effect, it's always a particle. When it comes to interference, then it's wave. Okay, over here. So and also the constant speed through a vacuum, that's wave. Where is it? Wait. Here. Radiant energy has a constant speed in the vacuum. Uh, radiant energy shows interference like waves. So when it's interference, it's like waves. Uh, radiant energy is I think waves also. Okay. المهم, where was I? Here, okay, radiant. Hold up. The light leaf spot. Okay. So look here on film. On a film, it's gonna be particle, consistent with the particle model. Because I think this came in the MS. On film, it's particles. Okay, you can read through this when you want, uh, but these are important. Okay, to travel through speed, wave model, photoelectric effect is a particle, and interference patterns a wave model. Question 13. The principle of conservation of energy states that the energy of an isolated system يعني دايما isolated remains constant. Okay, energy isn't lost in any system, it just changes its nature, okay, or type. Okay, here as the current flows in an electric circuit, battery provides to the circuit. So obviously energy is flowing from the battery to the circuit. يعني وشو السؤال الغبي صراحة. Question 15. Which objects contain chemical potential energy? This was in AMS before. دايما food and fossil fuel are the ones that contain chemical energy. It's in the book كمان. Which of the following statements are true? Electromagnetic radiation can propagate in a medium. Okay, obviously radiation can go through any medium. It can propagate in vacuum, so it can be any عادي in vacuum. And propagating in vacuum is the same as saying it can travel outside matter, because vacuum there's no matter, it's empty. Okay, so these three. Is it an example of nuclear? Obviously not. The photoelectric effect supports the wave nature. No, we said supports the particle nature. Okay, thank you so much for watching and good luck.